Okay, Assalamu alaikum. So this is the lecture that we couldn't complete yesterday because of power issues at my end. So I'm going to go through all this material and I'll try to write code that will help you understand this material. And not just this material, but I have also posted today's lab tasks on the Classroom for Data Structures and Object-Oriented Programming Lab. So that material is also available on Google Classroom. You can go to the material. I guess the file it is self-explanatory and you can like easily understand it, except for maybe the portion or the material on static data members. So we'll walk through all this material. The first thing that we want to talk about is how objects are basically allocated memory. Okay, so objects, classes and objects, as we have studied so far, they are basically encapsulation of two things. One is the data members or attributes, the other is the member functions or the behavior of the class. So they are basically an encapsulation of these two quantities, the attributes and the behavior. Now it makes sense, like if we have 10 objects, so all those 10 objects can have different attributes. So it makes sense that those attributes should be stored separately. That is, all the data members or attributes of an object should have a separate copy for that object. So if we have data members, non-static data members that we call here, and you will know why do we call them non-static data members. So the non-static data members, their copy is maintained per object. So for each object there is one copy of the non-static data members. So for example, the classes that we have written so far, so my time class, say for example, so my time class has had 4 data members, int hours, int minutes, int seconds, and int days. So for each my time object, we'll have a separate copy of each of these data members. So say for example, we have a my time object T1. So it will have a separate copy of the hours, minutes, seconds, and days data members or attributes. Similarly, if we have another object T2, it will have a separate copy of these 4 data members. T3 will have a separate copy. T4 will have a separate copy. So this is very reasonable. This is how it should be. Each object will have the same number of attributes, but those attributes can have different values. So in order to be able to store those different values, we need to have different memory locations for each object where those attributes can be stored. Okay, so this is very sensible, and this is it makes like complete sense. Now what about the member functions? The member functions, their copies are not maintained for each object. There's only one copy of each member function for all the objects of the class. Okay, so whether that member function is the constructor function, whether that member function is any other function, a get function or a set function or a print function or a reset function, any member function, there's only one copy of that member function for all the objects in the class. Okay, so it also makes sense, like there is no value in storing multiple copies of the same code for different objects. Okay, so we can basically use this code, a single copy of all the member functions. We can use it in a smart way for each object. So whenever you are invoking or calling a function, so that function is called for a single object. So there is like no parallel execution. So there is no execution as t1 dot print and t2 dot print and t3. That does not happen simultaneously. At one time, only one object is accessing a member function. So it makes sense that there is only one copy of the member function. Like you don't need multiple copies of the member functions, because the copies are not going to be executed at the same time. The print function is not going to be executed for T1 and T2 and T3 and T4 all at the same time. So at any given time, the print function is going to be executed for just one object. You may either say T1.print or T2.print or T3.print. So that single statement would be executed, and that would invoke the execution of the print function for one object, either T1, T2, T3 or T4. So when the print function is being executed, it needs to know for which particular object it has been called. And how does it know about that? So it knows about that by using a special pointer. So that pointer is called this pointer. So each function, whether it is the constructor function, whether it is any other member function, it receives the address of the object for which it is invoked. So say for example, if in the main program we say t1.print, so the print function is being invoked for the object t1. So the print function will receive the address of the object t1 in a special pointer called this. Okay, so you can access this pointer. So that is how, like, if there you can have, a question that if we have a single copy of each member function for the entire class, for all the objects of a class, then how does that member function know which object has invoked it? And if the print function says cout hours, minutes and seconds, so the hours, minutes and seconds of which particular object are going to be printed, the values of these data members for which particular object are going to be printed. So every function needs to know about that. For example, if you say get hours, and inside get hours we say return hours, so return which hours, hours for T1, T2, T3 or T4, which hours would be returned. So get hours function needs to know about that, and it is given this information through a pointer, and that pointer is called this pointer. Okay, so we learn how to use it. So this is the first thing that we wanted to talk about in this particular session. Okay, so objects, non-static data members, there is one copy for each object. Member functions, one copy for all the objects of a class. Okay, so whether the objects are 1000 or 10 or just one, so the member functions, there will be only one copy of the member functions of that class inside the random access memory. But if we have non-static data members, so for each object it will have a separate copy. If we have 10 objects, there will be 10 copies of those data members. If we have 1000 objects, there will be 1000 copies of those data members. Okay. Similarly, a non-static member function gets the address of the object for which it was invoked in this pointer. So we talked about it, and we will illustrate it using in our code. So we'll write some code after I talk about both these things, and then in that code we'll demonstrate whatever we just talked about, these objects in memory. The next thing that I want to talk about here is about static members, and by static members we mean static data members and static member functions both. So I hope you know the keyword static. Okay, so we talked about storage class of variables in the very beginning of this course, and in that we talked about two types of storage classes, although there are other types of storage classes, but we specifically talked about only two types of storage classes. One was the automatic storage class and the other was a static storage class. So automatic storage class means a variable will have an automatic storage class if it is automatically created and destroyed. Now, when is it automatically created and destroyed? Whenever it comes, like, in the scope, it is created. Whenever it goes out of scope, it is destroyed. Okay, So these are automatic variables. Any local variable, it is fundamentally automatic. If you simply declare a local variable inside any block, it is by default automatic. That is, it will be created whenever the scope of the program changes to that block. It will be created. When the scope goes out of that block, so it will be destroyed. Okay, that is, these are automatic variables. On the contrary, we also have static variables. Now, static variables, they are created only once and they are destroyed only once. They are not automatically created and destroyed again and again, depending upon the fact that how many times do you enter that scope. That is not the case of static data members. Static data members are created when the program is initialized, and they are destroyed when the entire program is taken off the memory. Okay, so we talked about the static data members and static variables and automatic variables, and that discussion was without the context of classes and object-oriented programming. Inside object-oriented programming, inside classes, static members have a different connotation. They have a different meaning. So static members, for example, static data members. Static data members are those data members which are not part of any object. Okay, so they are not part of any object. They are not tied to any particular object. In fact, they are tied to the class. So there is only one copy of the static data member for the entire class. Okay, not for every object. Like we talked about these attributes, these are non-static attributes. So non-static attributes, uh, they are part of the object. Okay, so these attributes are part of the object. If they are part of the object, that means we need to have different copies of these attributes for each object. So T1 should have its own copy of these attributes, T2 should have its own copy of these attributes, T3 should have its own copy of these attributes. Similarly, all the other objects of type myTime, they should have their own copy of these attributes, because these are non-static data members. Static data members, on the other hand, they are not part of any object. They belong to the class. So they store class-wide information. They store class-wide information. That is what they do. So static data members, there's just one copy for the entire class. Okay, they are not part of any object. Hence, their declaration is not considered their definition. So there's a special way of declaring and defining static variables. We learn about that. Okay, I have also mentioned it in the lab tasks for today, so you can read that, and you can learn how to create static data members. But here too, like, I'll demonstrate how to create a static data member and how to declare and define it. Now, since static data members are not part of any object, therefore, in order to access those objects, you do not need any object. You do not need any reference to any object. So you can access a static data member or static member function using the class name, just the class name. So I'll show you how to do that. And again, I have mentioned that in the lab task for today as well. So static data members, since they are not part of any object, therefore they do not require the existence of any object for their existence. They can stand alone by themselves. So they don't need any object to exist to come into being. So they are there. Okay, they're always there. Although we said that we don't need any object to access a static data member or member function, but the member access rules apply the same way as they apply to any other variable. Okay, so they can be private, they can be protected, they can be public. A public static member, whether it is a data member or a member function, it would be accessible by all. A private data member that is static, it will only be accessible by the member functions of that class, not outside that class. So those rules very much apply here. Okay. Similarly, static data members, like, they can be accessed by static member functions and non-static member functions. Okay. So static data members can be accessed by any member function. Why? Like, a static member function can always access it. Okay. And a non-static member function can also access it. A non-static member function, so we will differentiate between these two. You can declare a member function as static and non-static as well. Okay. So again, when a member function is static, so it is not connected to any object. It does not receive the address of the particular object. Okay. It does not receive the address of any object. So when a static member function does not receive the address of any object, it does not have this pointer. That means it cannot access the non-static data members and member functions. Okay. So static member functions, they can only access static data members. They cannot access non-static data members. Why? Because non-static data members, they require the existence of an object for their existence. They can only exist if an object exists. They cannot exist without an object. So that's why a static member function cannot access non-static data members, because they may not exist. If it is trying to access them, those data members, because of their non-static nature, they may not exist because they need an object to exist, and that object might not be created. And a static member function can be invoked without the existence of any object. So you can call a static member function without having any object of a class. Okay. So without creating any object, you can invoke the static member function. Okay. Again, this may sound strange, because the other member functions, the normal member function, that the non-static member functions that we have been creating so far, those member functions can only be called if there is an object of that class inside the memory. If there is no object in memory, so you cannot invoke any of those member functions. Okay. But a static member function is special in a way that it is not connected to any object. You can call it without creating or instantiating any object of that class. Okay. So you can invoke it just using the name of the class. Okay. So we will demonstrate that as well. Static member function must be declared and defined the same way as static data members. So they are also declared. In fact, you can say that a static data member is declared and defined in the same way as a static member function or any other member function. Okay. Whatever we'll do in the case of static data members, we do not do that in the case of non-static data members. We do that in the case of in the case of member functions. Okay. So we'll do something like that in the case of static data members. Now, why do you need static data members? This can be a question, and it would be a valid question. Why do we need to have a static data member? So static data members are required to store class-wide information that is the same for the entire class. Okay. So we use a static variable to do that, a static data member to do that. For example, if you are working on a problem and that problem involves writing code or software for automating systems in our university, say for example, and while writing that code, you think that you require classes to basically model students and teachers and staff all these people. So you have a student class, you have a teacher class, you have a staff class, okay? And all these classes have information about the university, or the name of the university, or name of organization, for example. Now the name of organization is going to be the same for all the teachers, all the students, and all the staff members, the other ancillary staff members, okay? So the name of the organization, that is University of Engineering and Technology Peshawar, it is going to be the same for all the students, teachers, and ancillary staff. So if you are creating objects, a student object and a teacher object and an ancillary staff object, so all these objects will basically store information about the organization that they are, the name of their employer or organization or university. So they'll store that information. Now it does not make any sense that information is common. For example, all the teachers teaching in this university, their employer is UET Peshawar. All the students studying in this university, their university is UET Peshawar. So it does not make any sense to store this information repeatedly for each student in the random access memory. So if I am creating 100 student objects, I do not need to store this information for each student separately, because it is the same information, it is repeating. I can store this information in a variable, in a static data member, because the static data member it stores information for the entire class, okay? So it is class wide information, so we can have for all the students, we can have the name of university as a static variable, so it will be just one copy for all the students. For all the teachers, we can have the name of employer as just one static data member, so it will be just one copy for all the teachers, okay? So the utility of static data members comes in these cases. And why do we need static member functions? Because if you have static data members and you want to access that data member, and at times you may not have any object or any reference to an object, and you still want to access those data members, so you can have a static member function, and the static member function would be able to access those data members without requiring a reference to an object, okay? So this is what we wanted to talk about, static data members and static member functions. And now I'll write some code. So I'll create some dummy class, and in that dummy class, or maybe I'll rewrite the myTime class, a very simplified version of the myTime class. Maybe I'll write that, and it will be a very simplified version of it, and I'll write it to demonstrate these concepts. One, the concepts of objects in memory. Two, static data members and static member functions. So let's write that code. I have created some code, like I have created all these files. Let us write classes. So let us create the same myTime class, okay? So we are creating the same myTime class, and or let us create, instead of myTime, let us name it as timers, class timer, okay? So let us change the name. So class timer, and private, let us declare its data members, int hours, int minutes, int seconds, okay? So right now let's have just these three data members. and then we have public. Okay, so we have public. Let us write a constructor. Yes, let us write a default constructor. Timer. This would be the default constructor. This would be the overloaded constructor. Int h, int m, and int s. Okay, so these two constructors are enough. We are not going to overload the copy constructor, and we are not going to have the destructor as well. We'll see if we need it, then we write one, but I hope we won't need it. Okay, so let me have one function to print the timer object. So say we want to print it, void print. Okay, so we'll have a function to print the timer object. And what else? I guess like we don't need anything else. These are going to be enough for the time being. Okay, because we want to demonstrate just these two concepts. Now let us implement these functions. So in order to implement these functions, I need to include what? One, I need to include iostream header file because I'll be doing some printing. Two, I need to include the header file that contains the definitions of these classes, and I need to use the standard namespace to be able to use the cout and cnopt libraries if I want to use. Okay, let's paste the signatures. Okay, so this is basically the constructor, default constructor of the timer class. Okay, and let me okay, now we can implement it. Okay, so this is the default constructor. Okay, timer, this is the default constructor. So here we would print just one statement. We'll say cout a default timer object created at address, and then I'm going to print this. So this pointer is basically stored in the keyword this, so you can use the keyword this to access this pointer. So it will have the pointer of the object for which this constructor function was called. Okay, so that is a newly created object. Let us initialize its values. Let us use the default, the member initializer list. Okay, so hours 0, minutes 0 and seconds 0. Okay, so we are initializing it using the member initializer list. Now let us copy that and let us paste it here. Now we are not doing any validation. Okay, we're trying to keep things simple and just trying to demonstrate these new concepts. So let us do the initialization here, and then let us say an overloaded timer. Let us get rid of the timer object created at address this. Okay, and let us see how the print function would work. Okay, so print is again, so we are just going to print the values of the object, but first let us say printing the timer object at. So let us print the address of the timer object, okay, so that we know which timer object is being printed, and then print the values. So print hours, and then a colon, and then minutes, and then a colon, and then seconds, and an inline character. Okay, so we are printing this pointer. In fact, we are using this keyword. So maybe this is the first time that you have seen this keyword. This is a keyword. This THIS is a keyword. Okay, it is a special word, but it is a pointer. It stores the address of the object for which this function is being called. Now, which object is that? Okay, so let us see. So let us include our header file that we just created. Okay, and let us create some objects and then call the print function for those objects. Okay, so let us say what is our class is timer, capital T. Let me make it small t. Okay, small t, to keep things simple, or it's okay, capital is also fine, no problem. Okay, so let us create some timer objects. Timer, say t1. Okay, let us create it by invoking the default constructor. Then timer t2, and t2 is this time, say it is the time right now, 7 29 and say 20 seconds. Okay, this is t2. Let us create t3. t3 is the time when the lab would start, say 8:30. Okay, I guess 3 objects are enough. So let's first print the address of t1. Like, what is the address of t1? Cout address of t1 is equal to, and then the address of t1. Okay, and then inline character, and then say we call t1 dot print. Okay, then we'll repeat this for the other objects as well. Then we'll say address of t2, and we'll print address of t2, and then we'll say t2 dot print, and similarly we'll repeat it for the third object, address of t3, address of t3, and then t3 dot print. Okay, so let's see, the fun is all in the execution. So let us execute it and see the output. So there we will basically learn something. Okay, now when this statement is executed, the default constructor is called, and this message is printed: a default timer object created at address 6DFEE4. Okay, and that is the address of t1. Okay, address of t1. When the default constructor is called for t1, this pointer has the address of t1, address of t1. Okay, when the overloaded constructor is called for t2, overloaded timer object created at address 6DFED8, address of t2 is 6DFED8. Okay, when the overloaded constructor is called for t3, again we print an overloaded timer object created at address 6DFECC, and this is the address of t3. Okay, similarly, look here, when you say t1 dot print, then you are printing the timer object at 6DFEE4. This is the address of t1. So the print function has the address of T1 object. That's why it can access the data members of T1, which T1 has a separate copy of hours, minutes, and seconds. How can the print function access the copy of data members of T1? Because it has the address of T1 in this pointer. Similarly, when you print T2, when you say T2 dot print, so this is the address of T2. This is the address of T2, and when the print function is called, so it also has the address of T2. Okay, and because it has this address in this pointer, it can access its data members. So inside the print function, when you say hours, minutes, and seconds, so you can assume that here you have this arrow hours, this arrow minutes, this arrow seconds. Okay, you don't explicitly write it, but you can implicitly assume that hours means this arrow hours, minutes means this arrow minutes, seconds means this arrow seconds, and this is a pointer which contains the address of the object for which the function has been invoked. If you say T2.print, this will contain the address of T2. If you say T1.print, this pointer will have the address of T1. So I hope this thing is clear to you. Okay, this thing is clear to you. So what is the utility of this pointer? And again, in the lab tasks, I have given you a task related to this activity, so you will be doing it again. Okay, now the second part of it. So let me it's okay, we can retain this code, no problem. Let us add something. Now we have talked about static data members and static member functions, and to this class we will add a static data member and a static member function. Okay, we'll add that. So the static data member that we want to add is this data member. It is a private data member, static. When you want to specify that my data member is a static data member, you have to use the keyword static. So when you say static int, so we want to add a data member that will store the amount of timers that we have in RAM. Okay, say for example, in this program we created 3 timers. Okay, T1, T2, T3. So we want to have this information with us. Okay, how many timers are there in RAM at the moment? So whenever a timer object is created, we want to count it. Okay, so how can you do that? So for that you need a variable that stores this information. So this information is class-wide information. Okay, because we want to count the number of timers that we have. So let us call this variable as static int timers. Okay, static int timers. So this is the variable that we have, and we want to write a function for it that is a static member function. So we want, and it will read basically the number of timers. So we want to how can you do that? You can say static int get timers. So this is our static member function. Okay, now static member function, like it is just like the normal member functions that you have, except for the keyword static, and except for the fact that it is not connected to any object. It does not receive this pointer. Okay, so it does not know about any object. It does not know about any object, and this function can be called without any reference to an object. So even if there is no object, you can still call this function, the get timers function. Okay, you can call it. So why did I say that it is similar? It is similar when you're writing code. Like if you want to implement, here we have declared it, and now we want to define it. So the definition is simple. Like how would you define it? Let us copy and paste it here. So we want to define this function. So when you want to define this function, you don't need to use this keyword static here in the definition. Here, you don't need that. You just need to say timer and then the scope resolution operator, get timers, and then you need to write the code, return timers. Okay, the number of timers that you have. That is its function. We want to know how many timers do we have in RAM. Now, implementing, like defining a static member function is the same as defining a non-static member function, except for the fact that you don't use the static keyword here in the definition. Okay, but defining a static data member is not the same. Now, these data members that you have, you do not redefine them in this file, in our classes.c++ file. Okay, why? Because they are part of the object, so only the class level definition of these variables is enough. But this static data member, it is not part of any object. So for the C++ compiler, its class level definition, this is the class level definition of this data member, this is not enough. Okay, we need to define it in globally as well. So we need to have a definition, its file level definition as well. So you need to redefine it here. Okay, and that is simple. You don't need to use the keyword static here. Again, you just need to say static, sorry, int timers, and then timer class timer, and then the scope resolution operator timers. I guess that is what you need to say. Okay, so we need to define it at the file level as well. Now this is part of the syntax for using static data members, so you better remember that. Okay, so we have to do it this way. Okay, so you have to follow this syntax for defining static data members and static member functions. Now, how do we modify this static data member? You don't need to initialize it. By default it will be initialized to 0. Okay, so you don't need to worry about that. Now this variable is going to keep the count of timers, how many timers have been created. Okay, so whenever a timer is created, some constructor function is called. So what we can do is we can say increment timers whenever the default constructor is called, whenever the overloaded constructor is called. Okay, and we need to decrement it whenever the destructor is called. Okay, so whenever the destructor is called, we need to decrement this variable because a timer object would be destroyed. Okay, so this is what we need to do. Timer, yes, so this is the destructor. Here we will decrement the timers variable, and let us print a message. A timer has been destroyed. A timer object, a timer has been removed from the address. Okay, so let us print the address as well so that we know which timer has been removed. Okay, so let us test this code. Okay, first of all, we said that we can access a static member function without creating any object. So here we have not created any object. So here we want to print a message, a number of timers in RAM right now. So we want to print that number. So how can we print it? So we have a get timers function. Okay, a static get timers function, we can call it, and this function is in the class timer. So we can say timer get timers. Okay, and so it will return us the number of timers. we haven't created any object. Okay, we are creating objects here. Once we start creating objects, you can print this message afterwards as well. So you can, after creating t1, you can say number of timers in RAM right now, and now you can say t1 dot get time, t1 dot get timers. So you can call it like that as well, like just like a normal member function. Okay, you can do that. And here you can copy and paste this code again. So now we'll have three objects. Let us create another object, timer, and this time let us create it on the heap. T4 is equal to new timer, and this is a very dangerous kind of timer. ठीक है, 12 बजे इसमें. Okay, so now we have one timer on the heap. So why did I create it on the heap? Because I can delete it, okay, at will. So when I delete it, then I can print the number of timers. So let me delete it. Let us delete it. Delete T4. Okay. This will invoke the destructor, and then let us print the number of timers in RAM right now once again. Okay. So the number of timers would be decreased by 1. So here it would be, say, 4. Here again 3. And then when the main program is it is done executing, then all the timer objects would be destroyed, so it will again be returned to 0, but we won't know about that. Okay, we can know about that, but we won't. Okay, so let us build and run this code and see if it runs fine. Okay, so it runs just fine, just the way we explained, we expected it. Okay, so let us look at the first statement. Number of timers in RAM right now. Timer, and then the scope resolution operator get timers. Okay, so number of timers in RAM right now is 0. No timer object has been created, and still you can call this function. Now you can try it for other member functions, the non-static member functions, and you won't be able to do it. Okay, if I remember, I'll try it. Otherwise, I ask you to do that in the lab report, lab tasks, as well as I'm asking you here that you should try calling the non-static member functions using the class name without having a reference. You won't be able to do that. Okay, but here in the case of static member function, you can do that because it is not connected to any object. It is independent of all the objects. Okay, so then we create T1, and then we have the number of timers in RAM right now 1. Then we create T2 and T3, and then the number of timer objects is 3. Then we create T4 on the heap, and its address is very different, and number of timers in RAM becomes then 4. Then we delete T4, but we delete it towards the very end. Okay, so here that message is printed. A timer has been removed from the address 896CD0. 896CD0. So it is removed, and then the number of timers is 3. So our variable is keeping a good count, a correct count of all the and then when the other timers T1, T2 and T3 are removed, so you get these messages. Okay, so our timer variable is doing whatever it was meant to do. Okay, so I hope I was able to demonstrate all these concepts. Okay, so what were the concepts? So we talked about objects in memory and this pointer, and the importance of this pointer, and the fact that the member functions have access to the object for which they are invoked using this pointer. So we were able to demonstrate that. Then I showed you how to declare and define a static data member. how to declare and define a static member function, and how to call them, and how to maintain a static data member. Okay, so I hope whatever this is what we wanted to cover yesterday, but we couldn't because of the power issues that I had. So I am recording this session so that you can listen to it. And in today's lab, like, we'll follow a different format. I'll post it on the class web as well. And if the power situation here is good, and if we have time, uh, so maybe we will have a short online session. But I think it is not necessary, that session, because in that session I'll be doing the same talking. Okay, so I have provided you the task, and you have this lecture, so you listen to it and you go through a task, you will be able to do it. Okay, so given whatever we learned yesterday and today, so you'll be able to do that task. So all you need to do is do that task at your own comfort. Okay, so there are no time restrictions from 8:30 to say 11:30 section A, and then from that to some other time section B. So I'll give you time until say 6 p.m. today, and until that time, 6 p.m. today, you will be required to complete this task and write the report and upload it. Okay, so it may sound a little difficult, but whatever you do, how like, if you are able to complete all the tasks, fine. Maybe we can extend it. I can extend the date to say tomorrow, so that you start working from today on this lab session, and you finish it by tomorrow, and you submit everything along with the code by tomorrow. So let me make it say tomorrow. So I'll create an assignment in the data structures and OOP lab course, and in that lab course you will complete the tasks that I assigned you today, lab number 4. You have time until tomorrow. You will complete all those tasks, and you will submit the report and the code online. So I will basically tell you how to do it. I'll create the assignment, and you will be notified. So you will have enough time. You should not waste any time. You should start working from the due time of your lab. Say start working from 8:30, and the other section should start working from 11:30 and complete it by tomorrow. So you should not be wasting time. So I'm giving you this room because I know, like, there can be power fluctuations, there can be other issues, many issues. Like, if you are at home, uh, the folks at home, they think that you are available and taking classes, or this is not a good enough excuse for them, may not be a good enough excuse. So I'm giving you flexibility in time. You have time until tomorrow, but you have to complete this task, and you have to submit it by tomorrow. So every week you will be able to submit your lab report, and the lab report, I have uploaded this PDF file, but in the post that I'll make on this course, on this Google Classroom for the lab, I'll tell you how you can submit that report. Okay, so the means will also be communicated to you. What else did I want to talk? So I guess if you listen to this lecture, and if you read the handout for the lab, you will have no problem in doing all the tasks. If you have, I guess you won't. I hope you won't have any problem. But if you still have, you can, like, always comment and ask questions. That is not a problem. If you have any problems, so we'll do that. Okay, I guess I have nothing more to say, so I'll end it here, and I will upload this video on YouTube, and I'll share the link on the class page on Google Classroom, and then you can get on with the lab. So you should do it at home, at your own convenience, but you have to complete it by tomorrow. Okay, so everything that about this lab must be submitted by tomorrow. Regarding the previous labs, so I'll make an announcement about that as well. I guess 2 lab reports have been submitted in hard form. The last one, the lab report for third one, so I'll create something for that so that you can submit it online. Okay, so but right now lab number 4 is the most urgent, so you should do something about it. Okay, that's enough. Thank you and see you next time.